Hi, good evening, and welcome to the ZP Developer Zone webinar. So we like to do this normally live. This evening the Wi-Fi is a little bit slow, so I'm going to unfortunately record it. But let me jump straight into it and just say that we like to do this webinar once a week, and it's really just answering technical questions that have come in during the week. So let me dive straight into it and say the date on this is the 30th of May, though I have gone a little bit early, and today's the 29th of May. And we've got 4 questions that are, I think there's 4 or 5 questions I want to answer. One of them is about phosphate sensors for activated sludge. Really interested in phosphate. Unfortunately, it is essentially getting into the water system. It causes these kind of algae blooms, or through a process called nitrification, and the algae multiplies, the oxygen is depleted, and the fish die. So a really important thing to be working on and solving. Another questioner here is asking about calcium sensors, which I will discuss. And another questioner here is really asking about sort of biologically relevant molecules like I want to say testosterone, but actually I think I'm meaning more things like sort of serotonin, etc. So I will talk about that. Another question is about sodium and magnesium. We definitely have a sodium sensor on the ZP website. We also have calcium as well. So if you could do sodium and calcium, you could definitely do magnesium, but we haven't done it yet. If somebody's interested in magnesium, then we can do a sort of paid-for program where we can quickly develop a magnesium sensor. Last question of the evening is about measuring the pH in some, I'd call it runoff water. And I will discuss how to use a ZP sensor for measuring the pH of runoff water. There are some upcoming webinars. If you're interested in doing point of need or point of care type testing, then there's a webinar on the 13th of June. We do 2 sessions, one in the morning and one in the afternoon. And the one in the morning works for people in, for example, in South Korea. The one in the afternoon will work well for people in North America, for example. We also have one on wearables. So if you're more interested in wearable biosensors, again, we do one on the 19th of June, one in the morning. That will work well for people in India. And one in the afternoon, that will work well for people in Canada, for example. The academic research is also covered at ZP. We're very interested, almost passionate, well, definitely passionate about actually moving technologies onto the market. I'm going to do a live demonstration in a minute, and that live demonstration is relevant to people interested in sodium, magnesium, phosphate, pH, and I'll do it live here in a minute. But we have 2 webinars for academic researchers, and it's really about translating science into products. We do one in the morning, which will be good for people in Australia, and one in the afternoon that will be good for people in Peru, for example. Any kind of links that you see, by the way, I'll also put the links underneath the video as well. So question number 1 is about phosphate sensors for activated sludge. So activated sludge is kind of part of the water purification process. I can understand why they were interested in phosphates. I think phosphates must be really quite tricky to remove, and even in low levels it's quite active. When I say active, it's very good at nitrification, or I should call it eutrophication, and that ends up causing problems in the water systems. Now if you're interested in phosphate, measuring phosphate, we have a few platforms. One of them is the SensiOil platform, and I should just say I've got a SensiOil in front of me now. So if you're interested in measuring pH in runoff water, for example, this will be relevant. If you're interested in measuring sodium in soil, this will be relevant. If you're interested in measuring phosphate in activated sludge, this will be relevant as well. With that said, let me go back to, so we've got the SensiOil platform, which is also available in a kind of wearables, but I think the most matured part of this platform is actually this point of need kind of form factor that I've got here. But we also have wearables. Now, few questioners today really what they actually need. If you're measuring the pH in runoff water, I think you're actually looking for a sort of sampling system plus pH sensor. If you're interested in measuring activated sludge, you probably need a full sampling system and then the sensor as well. It's similarly, if you're measuring sodium in an agricultural, horticultural application, then you probably need to be using the kind of sampling system as well. Just in its most simplest, we would take the sensor, for example, put it in a flow cell with a pump system, and then there would be the sample, and we would just basically sort of suck the sample through and over the sensor. Now, question number 5, which is really talking about the runoff of water and measuring the pH of runoff water. I'm going to do this again, but I'll do this in a bit more detail. But just to say that at ZP, we have sensors, but sometimes you actually need to put the sensors into a complete system in order to kind of make use of them. It's easy when you're willing to bring the sample to the sensor. So in this case, I can just kind of bring the sample to the sensor, and you can just make a measurement and then essentially get rid of the sensor. The reason that's kind of relevant actually is because I'm going to do a little demonstration in a short while. But I'm not going to do it quite yet, but whilst I'm on that screen, I'm just going to put in a fresh sensor in there, and we will do that demonstration pretty shortly. Yeah, that one looks good. Okay, let me go back to the screen here and just say, okay, so if you're interested in activated sludge, if you were willing to take the sludge and essentially just put it onto the sensor, that's easy. But if in fact most people actually would want to do online monitoring, and that's going to take a sort of sample system, as I'm sort of illustrating here, where we had a sort of prototype system, but this whole workflow about sensors, electronics, and up to the cloud is relevant whether we're talking about this kind of system or a point of need testing system. Just to say, at ZP we do have a lot of electrochemical biosensors, so don't think that we're just this kind of sodium, the calcium, the pH company. No, we do have a whole range of sensors. If you're following along with this video, whether you're interested in calcium or sodium or pH, rather amusingly actually, this is if you've got something like a Google operating system, you're running Android, maybe it's a Samsung. I think I've got a Samsung in front of me here. Please scan this QR code. It will become important in a bit. If you're not on Android, in fact you're on iOS phone, an Apple phone, then please scan this QR code, because this will become relevant, maybe even nowish actually. We've got all these different QR codes, and for different, let's say, targets, we have different QR codes, and I'll show you what the relevance of this is. First of all, you can use these different, once you've installed that app on your phone, you can scan these different QR codes, and it'll soon become obvious to you actually what's going on here. But let me just go to here, because what I want to do is just want to show you that I've got a series of QR codes in front of me. Now, at ZP, we make biosensors, we make electronics, and actually we make all these things work together. So now what our business model is we do contract development, contract manufacturing for other people. So this is a kind of a platform in order that other people can realize their application. If you're trying to measure the runoff water and you're measuring the pH of runoff water, that's an application. And we could be involved in that, but we would bring a lot more to the party than just a pH sensor. We would end up bringing electronics, we would end up bringing cloud connectivity, we'd end up bringing the sensors. But let me just show you, this is the Sense It All app, so hopefully you saw the slides earlier on and you've installed the app. Once you've got the app on your phone, the app will allow you to, I'm going to just scan, I can scan different QR codes in front of me, and every time I scan a QR code, it changes actually, so at the moment I'm on pH, now I'm on nitrate, now I'm on total antioxidative status, maybe I'll go over here, now I'm on potassium. So now I'll just go back to pH, chili, ginger. So it's very easy. Now I haven't explained this yet, but this phone, this Samsung phone is actually in connection. This Android is actually in Bluetooth connection with this piece of hardware here. This is the Sense It All platform, and I'm going to do a little test for you now. And what I'll do is I'm going to take a sample here, and this really spells out. Maybe call this calcium. This really spells out what the now with Zimmer and Peacock, we've learned something from the technology world. In the technology world, people don't build sensors and electronics and everything from, well, they don't build everything from scratch. They actually build upon other people's technology stacks. So there's technology stacks, and you build upon somebody else's, and somebody else builds upon you. And all these things kind of talk to each other through using API, application program interface. at ZP, we're trying to bring that kind of way of thinking and product development actually to the deep tech industry. So biosensors is really a deep tech industry, but it should really be behaving more like a tech industry. So this is the first time you'll see that where a company where actually we made a technology stack that computer scientists in California universities could actually essentially bolt into and start making technologies and products on top of it. So let me take the sensor. Beautiful thing about the kind of sensors we make, they don't need much sample. That's a 50 microliter sample. The app, I'll go to assay, which I'm doing here, telling me, and I'm on to start measurement. So the hardware is now running. I know the hardware is running because actually there's an LED that's flashing away here, so that tells me that the hardware is running. I've also got a progress bar running in front of me as well. So at ZP, sure, we make sodium sensors, we make phosphate sensors, we make calcium sensors, but we make everything. Actually, we make a technology stack that means that other people can use our technology stack in their products and their ideas. It's our business model. So I've got a result here, but I just want to, I'm just looking to another screen because I've got another screen running here as well. And I will, yep, here it goes. So what I'm going to do is I'm going to change screens for a second. So I've got a cloud system called Julie. So at Zimmer and Peacock, I didn't put a sort of an illustration of this, but we make sensors, we make electronics, we make cloud connectivity, and we have a cloud system. All of these technologies are all designed, they stack on top of each other, so we actually end up delivering all the data to the cloud. I also just want to very quickly say, when I'll do it just very quickly, we also have an API built into this as well. So if you are interested, I mean, if you're a computer scientist or a developer and you're interested in APIs, etc., we do have an API built into this as well. With that said, let me go back and just say I just ran this this particular test. I can see my test name, my date. It's the evening here in London. The test time, the date, and I can also then see my raw signal, and I can see my results as well. So what am I saying here then? I'm saying very quickly that whether you're interested in phosphate, calcium, pH, ZP's business model is to really be part of the development team and the final, and also part of the manufacturing and supply chain. But we've made this system really open so that actually you can build your technology on top of what we're doing. So instead of spending what really takes, you know, most biosensor companies spends good 15 years doing what they do, and their rate of success is actually about 10%, which is really, let's say, poor. So what we're trying to do at ZP is increase people's likelihood of actually succeeding and making something that's actually useful, rather than just spending a lot of time and actually, you know, in the end it never really hit the market or never made an impact to the business. So now you'll see why all these QR codes are up here, and you can play with that later on. So question number 2, somebody's very interested in our calcium sensor. We have a calcium formulation. We've been making the calcium sensor for years. You can have it in different form factors. I would ask you to install this app. If you're on a Android, use this QR code. If you're on a if you're on iOS or Apple, use this QR code. And just as a hint, you're asking how the sensor works. Scan this QR code. What you're going to find out is ZP is really accelerating development by actually almost simplifying what it would take to make an application with a calcium sensor. Because now when you come to our website, you find, oh, here's a calcium sensor. Oh, here's some test solution so I can get going with testing it. Oh, here's the electronics for it. And any of these URLs, by the way, will also be underneath this video as well. Question number 3, somebody's very interested in biologically active molecules, dopamine, norepinephrine, epinephrine, serotonin, and I've done epinephrine twice there, so adrenaline. Just to say that our technology can definitely detect these kinds of molecules, and if you are interested in, let's say, serotonin and epinephrine, which is also adrenaline, then please don't hesitate to contact us at ZP. Question number 4. somebody's very interested in looking at sodium and magnesium. It's probably worth saying that we definitely do have a sodium sensor, and you can use it with our Sense It All platform. Number 5 is, this is the one, I'll put a little bit more thought into this, pH sensor for environmental samples. So you have a facility, the water's raining upon the facility, you want to measure the pH of that runoff water. So of ZP, we obviously have a lot of biosensors, including the pH. What's nice about our pH sensors, they're not solid state. So the problem with solid state in environmental application, the problem with traditional pH sensors in environmental applications is pH sensors actually require a lot of maintenance. Of course, with ZP, our pH sensors, our sodium sensors, our calcium sensors are actually all quite solid state. So there's a different degree of maintenance required for that. But it just say that it really would require ZP to be part of a program in order to make that kind of technology really work, because you need the sensor needs to be in a kind of flow cell, it needs to work with ZP electronics, which we can house, accordingly. So there's, we can do it, but this is not a off-the-shelf product. This is a project, I would say. And then obviously we need to sort of talk about, what kind of sample size we need, what kind of pumping we need in order to get those samples onto that sensor. And then, does that sensor need washing? Does it need calibration? So therefore, does it need reservoirs? So what I'm saying is ZP has a solid state pH sensor. ZP has the electronics for a solid state pH sensor. We even have the ability to drive that solid state pH sensor and even send the data to the cloud. But once you start trying to do environmental monitoring, then the technology does get more complicated, and ZP would have to do this as part of a program, which we can do, but it's not just people can just buy a pH sensor and start making environmental applications. Unfortunately, it would require a paid engagement with ZP in order to sort of troubleshoot, make it all work together. So question number 1, phosphate sensors for activated sludge. Yes, we have the phosphate sensor. Yes, we even have the electronics, but it needs to be those need to be integrated into a total sampling system. How do our calcium sensors work? Scan those QR codes and it will give you a bit of a hint. Question number 3, those molecules that were listed, we can definitely detect them on the Sense It All platform. We can today supply a sodium sensor. We don't have a magnesium sensor, but to be honest with you, magnesium and calcium are similar enough that we can develop it. And if you've got a problem with conventional pH sensors, I can understand that. They're full of liquids, they need a lot of maintenance, and I would agree that the solid state pH sensors from ZP are actually a better option, but it does require a paid engagement with ZP in order to sort of build a system around that. So what I want to say is thank you very much. If you have any questions on ZP, don't hesitate to reach out to us, and I will put links underneath the video. Okay, thanks so much. Bye bye.